Characteristics of quadratic functions. So today we're going to be graphing quadratics from three separate forms. And so the first form we're going to be graphing from is the vertex form. So if we kind of review just a little bit, quadratics can either be facing up or down. Their vertex is at the highest or the lowest point. So these are both vertices. They have an axis of symmetry vertically running right through the center. And they can have two zeros, two x-intercepts, or one x-intercept, or no x-intercepts. So with vertex form, this is the vertex form of a quadratic function. So the a value in the front, that is your stretch or compression factor. The important thing about the a value is that if you have a negative a, that means your graph is opening down. So it's opposite the direction of the parent function. If you have a positive a value, it opens upwards. For vertex form, the reason why it's called vertex form is because you can determine the vertex directly from the equation. So you find the vertex at h, comma, k. H is found on the inside of the square, k is found on the outside. And the h value is always the opposite sign from the equation. So if the equation has a +2, your h is actually a -2. If the equation has a -3, your h is actually a +3. Here are your steps for graphing in vertex form. I'm going to do these steps, but I'm not going to read through them. So for example 1, it says graph f of x equals -2 times x plus 3 squared plus 4. So remember that f of x, this piece here, is just fancy for y. That's all that means. So the first thing we need to do with most quadratics is find the vertex. Basically, you have to have a vertex and two other points to graph a quadratic. So since this is in vertex form, the vertex is easy to find. This is your h, this is your k. So the vertex is going to be a -3, comma, a +4. The h is always opposite what it looks like in the equation. So since this says +3, my h is really a -3. Now, along with that, we also know the axis of symmetry, that vertical line that splits the parabola in half. That is x equals -3. So we're going to plot both of those things. So let's plot the vertex at -3, 4, and draw the axis of symmetry here at x equals -3. Now, I do need two coordinates to create a quadratic. I need two more. And so what we're going to do is, since vertex form doesn't give us much of anything else, the second thing we're going to do is we're going to find another point. Find another point. So that means I can choose any x value I want. I'm going to be strategic though. I don't want to choose x as 6 because eventually I'm going to have to square whatever x is. And if I take 6 and square it, I'm already at 36 and I only have 8 on my y's. So I'm going to pick something closer to this axis of symmetry. I'm going to pick, let's say, x equals -1. Choose any x value you want. So the coordinate so far is -1, comma, something. To find the y value, you're going to take this x and you're going to substitute it into this equation to figure out the y. So we've got y equals -2 times the x value of -1 plus 3 squared plus 4. And we're going to simplify this down. So order of operations say parentheses come first. So -1 plus 3 makes 2 squared plus 4. And the next part of order operations is the exponents next. So 2 squared is a 4. And now I can multiply. So -2 times 4 makes -8. And -8 plus 4 makes a -4. So the other coordinate that we're plotting is -1, -4. So -1, -4 is here. Now, because I have these 2 points and I know that my graph has to make either an upwards U or a downwards U, is I know it's going to be facing down, which makes sense if I take a look at my A value being negative. That means that this guy's going to open up downwards. So I need another coordinate. As I don't know what the left half looks like. I have the right half, I don't have the left half. Well, we're going to use the fact that this parabola is symmetrical to help me find the other side. So this purple dot, this purple coordinate, is 2 away from that axis of symmetry, which means the other coordinate also has to be 2 away. Use your symmetry line to find your third point. Now that we have a third point, we're going to connect these points with a parabola, which means a U-shaped curve. Guys, it's a curve, not a V. So make sure you connect these with an actual curve at the top or the bottom. So this is going to be the relative shape of my parabola. Pause the video, try example 2. Here's your solution for example 2. So the vertex is at -1, 0, -1 from the h on the inside of the square, and then 0 because there isn't anything added or subtracted on the outside. So my k value is a 0, which also makes the axis of symmetry x equal to -1. Then we're going to find another coordinate. So I chose x equals 0 and substituted x equals 0 into the original equation and got a y value of -3. Then use symmetry to find the third point. 0, -3 was 1 away from the axis of symmetry, so that the other coordinate also had to be 1 away. And we know that it should be opening down because the a value again is a negative. Now graphing with standard form. So standard form is what you usually use to solve quadratics, usually. Standard form is the ax squared plus bx plus c. And I want you to notice that here's another a. And I had a also in vertex form. These are the same a's. Just like m is always slope, this is the same a value, stretch or compression factor. So again, if a is negative, it's going to open down. If a is positive, it's going to open upwards. Now, the vertex is not something I can easily find from here because it's not in vertex form. There's no h, there's no k. But you can easily find the y-intercept. The c value is the y-intercept of your function at 0, whatever c is. So again, here are the steps. There is one thing I would like you to note in the steps is this formula here. This is how you find the x value of the vertex, or in other words, the axis of symmetry. That's how you find it. So for example 3, we're going to graph y equals 3x squared minus 6x minus 1. So the first thing I need is a vertex. I must have a vertex to graph my quadratic. Well, with standard form, I can't easily pick out the vertex, so I'm going to have to use the formula to find it. Negative b over 2a. So where do a and b come from? Well, 3 is your a, -6 is b, and -1 is c. A is always next to x squared, b is always next to x, and c is always the number without a variable. When we substitute these in, you need to note that the negative in front of b is part of your formula, and then you substitute b in next. And then 2 is part of your formula, and then you need to substitute a. So you may have some double negatives that you need to simplify. Negative and -6 make +6. 2 times 3 also makes +6, and we end up with a 1 as the x value of my vertex. So really what you just found is you just found that axis of symmetry. I know that the vertex has to lie on this line somewhere. I just need to figure out the y value that it has. So we know that it's going to be 1, something. Well, to find the y value, you have an x. Take that x and substitute it into your original equation to find your y. So y equals 3 times x squared, but x is a 1, minus 6 times x again, which is still a 1, minus 1. And we're just going to simplify this down to find the y value. So 1 squared is a 1. No more exponents. 3 times 1 makes 3. -6 times 1 makes -6, drop the -1, and add or subtract all those together, we end up with -4. So my vertex is at 1, -4. So there is my vertex. Now the second step is you need another coordinate. Well, it doesn't matter what other points you have, I need another one. Since we are in standard form, however, I can easily find the y-intercept. The y-intercept is that c value. And since c is equal to -1, that means your y-intercept is at 0, -1 right here. Now, if you can't remember that this is the y-intercept, you can still pick any x value along the x-axis, substitute it in to find its corresponding y value, and you will still get the correct quadratic graph. Now, since I have 2 points, I'm going to use symmetry. So this is 1 away. So my other point also has to be 1 away. So this guy is going to be facing upwards. And again, make sure there's a curve on the end of your graph. And it makes sense that it's facing up because my A value is positive, so it should be facing up. Pause the video, try example 4. And here's your solution for example 4. Your vertex is at -2, 9. A is a -2, B is a -8. So when you plug those in, make sure you keep your signs. Find the x first, take that x and substitute it back in to find a y value of 9. And then I can find any other point, but I know since this is standard form, the easiest point is that y-intercept right here at the c value of 1. The last part that we're going to do for today is graphing an intercept form. So intercept form is probably not one that you have seen before. So with intercept form, you can easily see the x-intercepts directly from the equation. So vertex form, you could easily find the vertex, and with intercept form, you can find the x-intercepts. So the a value, again, that's your stretch or compression factor. If there's a negative a, it opens up downward, and if there's a positive a, it opens upwards. So for the insides, P and Q, those two values are your x-intercepts. Now, there's another word that we use for x-intercepts. We also call them zeros. So be careful about that. If you see the word zeros, all that's asking you for is an x-intercept. So now we've got our intercepts are going to be P, 0, and then whatever Q, 0 is. Now we've got a minus here, which means these are also opposite signs, just like H. So P and Q are both opposite signs from the equation, since they both have negatives in front. So these two both have opposite signs. So with example 5, let's begin. Find what's easiest first. Since this is intercept form, the first thing that's easiest is finding those x-intercepts. That's what it will take the least amount of work. So P is a 3 and Q is a -1, which means my intercepts themselves are actually -3, 0 and +1, 0. The signs are opposite. This said a plus, so this means it's a minus. This said a negative, which means it's a positive. So let's plot those two coordinates. So -3, 0 and 1, 0. Now with every quadratic, I need a vertex. Now there is a formula. If you look in your steps, there is a formula to find the x value of the vertex here. However, you don't necessarily need that formula. The vertex is directly in half of the parabola. So if I have a quadratic, this shape, and I have a point here and a point here, the vertex and the axis of symmetry are directly in the center, which means this distance and this distance need to be equal. Well, I can figure that out by counting. If I count the spaces between my two zeros, because these are at the same height, so I have 1, 2, 3, 4 spaces in between, and I know that half of 4 is 2, which means my axis of symmetry must be 2 away from either coordinate. So this right here must be my axis of symmetry. So I found the axis of symmetry at x equals -1. Now, how does that help me? Well, I know that the vertex also has to be on this line somewhere. It may be at 7, it might be at 1, it may be at -5. I got to figure out where, but it's going to be on this vertical line somewhere. So the x value of the vertex is -1. All we need to do now is take this value and plug it in to find the y. So we're going to take y equals -2 times the x value of the vertex is -1 plus 3 times the x value again, which is -1 minus 1. And we're going to simplify. So again, order of operations, parentheses comes first. The stuff inside needs to be simplified. So -2 plus 3 makes 2, and -1 minus 1 makes -2. Now be careful, none of these are added or subtracted. These are all multiplied together. So take them in pieces. Multiply the first two, then take your result and multiply to the last one. So -2 times 2 makes -4, and -4 times the remaining -2 is a +8. So my vertex is at -1, 8. Now, you only need 3 coordinates for a parabola, and I have 3. I have the 2 intercepts from the equation and the vertex that I just found. So we don't even need to worry about symmetry anymore. So we're going to draw in our parabola. Pause the video, try example 6. Example 6. Your intercept should be at -1 and -5 because these are opposites. So this says a positive, so I need a negative on my coordinate. The vertex is at -3, 4. So these were 4 apart, so half of 4 is a 2, which means the axis of symmetry is 2 away from either 0. Now, if they were 5 apart, it would actually be 5/2 away. If they're 6 apart, that means the axis of symmetry is located 3 units inside. Then take your x equals -3, substitute into your equation up at the top to find your y value of a 4.